Solutions for quiz 8 for Math 95. In this, we're given a radical equation and asked to solve for x. The basic idea here is it's hard because we have this square root, but we can get rid of this square root if we isolate it. We can isolate it by subtracting 1 from both sides of the equation. Now it's all by itself. And the reason that's advantageous is now I can square both sides of the equation, and the square root is gone. So what I have is 2x plus 1 on the left. And on the right, if I expand this binomial, I get x squared minus 2x plus 1. So now I got to solve this equation. This equation is easier to solve than this equation because it doesn't have that radical. The basic idea when you have a quadratic equation like this is you want to set it equal to 0. So if I subtract 2x from both sides of the equation and subtract 1 from both sides of the equation, I'll get x squared minus 4x plus 0 equals 0. And this is nice. These are a little bit easier to solve. Both these terms have an x in them. So I could factor out that x. And I'll get x times x minus 4 equals 0. So if something times something equals 0, either x equals 0 or x minus 4 equals 0. But x minus 4 equals 0 is the same as x equals 4. Be careful on these radical equation problems. You always have to check your answers. What we will see is that one of these is not a solution. So if we plug 0 back in everywhere you see x, you get 2 times 0 plus 1, square root of that, plus 1 equals 0, question mark. You might already be able to see that this is false because the square root is not going to be a negative number. If I add 1 to that, I'm going to be some positive number. I'm not going to be 0. But we can go through the steps. 2 times 0 is 0, plus 1 is 1. So square root of 1 plus 1 equals 0, question mark? No. 1 plus 1 does not equal 0. So this is not a solution. Okay, what about this one? I think this one will end up working, but we'll check it anyways. If I go back to my original equation and put in a 4 everywhere I see x, and I'm saying is the square root of 9 plus 1 equal to 4, question mark? Yeah, it is. Because square root of 9 is 3. 3 plus 1 is 4. Cool, that works. This is an answer. It's the only answer. And I'm done with part 1. Part 2, we're dealing with complex numbers. Subtracting them, multiplying them, dividing them. All right. Subtracting them. You can pretty much just treat the I like it were a variable. So kind of think about it like it were an x. If I gave you this problem but it were an x there, what I'd hope you do is you take this negative here and you kind of distribute it to the two terms in these parentheses. Say that becomes negative 2 plus 3i. And then you combine like terms. You'd say 4 minus 2 is 2. 3i plus 3 more I would be 6i. And that's exactly what you do with complex numbers. Really just treat that I like it's a variable. So you get 2 plus 6i, that's our final answer. Same idea down here. If this were an x, what we'd have to do is FOIL. We'd have to do, let me set up little box method is how we were doing it in math, whatever that was, 65, I guess. So when you're multiplying binomials, one way to keep track of where everything goes is kind of this little box method. 2 times 4 is 8. 2 times 3i is 6i. 4 times negative 3i is negative 12i. So far we're just treating the i's like they're variables. Negative 3i times 3i is negative 9i squared. However, I squared is negative 1. So this is negative 9 times negative 1, positive 9. So what we get is that this thing is equal to 8 plus 6i minus 12i. Sure, I'll write it out. Minus 9i squared, which, as I noted over there, is 8 plus 6i minus 12i plus 9. And now if I combine like terms, 8 and 9 is 17. 6i minus 12i is negative 6i. So 17 minus 6i is my final answer. Guess to be consistent, I'll put a box around it. All right, now we're dividing here. The way you divide complex numbers is you multiply the numerator and the denominator by the complex conjugate of the denominator. Sounds worse than it is. Really all we're doing is we're going to multiply this fraction, the top and the bottom, by 2 minus 3i. Because we have 2 plus 3i here, we'll do 2 minus 3i. 2 plus 3i times 2 minus 3i. Alright, I guess we could do this again. You might not need to do this box method, because this is going to end up as a difference of squares in a sense. Oh, it's a little bit more confusing with the I in there. 2 times 2 is 4. 2 times negative 3i is negative 6i. But 2 times positive 3i is positive 6i. 3i times negative 3i is negative 9i squared. So what we get is, this is 4, sure I'll write it, minus 6i plus 6i minus 9i squared, which is 4. These cancel out, plus 9, which is 13. So what I'm saying here is the denominator, this times this, is just 13. By choosing the complex conjugate, we're guaranteed that we'll always end up with no i's left over when we multiply these two guys together. So what about the top? 4 plus 3i times 2 minus 3i. I guess I got to figure out what that's equal to. Unless I'm clever and I look up here, it's exactly what we figured out up here. 4 plus 3i, 2 minus 3i. We did that in part B. Figured out that that's just equal to 17 minus 6i. So what we get is this divided by this can be written as 17 minus 6i over 13. However, this is not a complex number. This is a quotient of a complex number and a real number. So we have to go one step further and say this is 17 thirteenths minus 6 thirteenths I. And now it fits this a plus bi form. This is one complex number, just like this is and this is. So this is our final answer. And I guess that is the end of the quiz.